In this video, we are working through some basic SOHCAHTOA past paper exam questions, which is something we will need to be able to do. In the next video, which I'll also link down below, we're going to work through some harder SOHCAHTOA problems, the SOHCAHTOA questions, where they hide SOHCAHTOA in other shapes than right-angled triangles. Still something we will need to be able to do, higher and foundation. So let's get the basic stuff down first. You can download these questions from the description down below, and let's do this. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay then, first up, I've stuck in this page from my brand new formula booklet, which is linked down below. It's basically our SOHCAHTOA Bible. If you've never done SOHCAHTOA or you need a proper refresher on how to do it, check out my original SOHCAHTOA playlist. Also, down below in the description, there's 3 videos: SOHCAHTOA Explained, SOHCAHTOA Finding Angles, and SOHCAHTOA Finding Sides. Okay then, first up, use trigonometry to work out the length x. Okay, so we know an angle, 72 degrees. Now, with respect to that angle, x is the opposite, and the 8 centimetre is the hypotenuse. So, we then run through SOHCAHTOA. So, is it SO? S-O-H? Yes, because we have O and H. So, that tells us then we are using sine. So, sine 72 is equal to the opposite, which is x, over the hypotenuse, which is 8. So, x over 8. Now to move that 8, multiply both sides through by 8. We get 8 sine 72 is equal to x. Whack 8 sine 72 into your calculator, and to 1 decimal place we get x is 7.6 centimeters. Okay, number 2. So this time we want to work out the size of angle x. So again, work out which sides we have. So we have the opposite and the adjacent. So is it SO? No. Ka? No. TOA? Yes, because we have O and A. Now TOA tells us tan x is opposite over adjacent, so 3 over 7. Now whenever you are looking for angles, your final step is to take the inverse trig function of the number on the right. So on your calculator, press shift, tan, and then 3/7. So x is the inverse tan of 3/7. Now again, to 1 decimal place, we get 23.2 degrees. Next up, use trigonometry to work out the size of angle x. Okay, so again, work out which sides we have. This time we have the adjacent and the hypotenuse. So is it so, no, ka, yes. So ka tells us cos x is the adjacent over the hypotenuse, so 9/10. So again, to get the angle x out of cos, take the inverse cos. So x is the inverse cos of 9/10, which again to one decimal place gives us 25.8 degrees. Next up, here is a right-angled triangle. Use trigonometry to work out the size of angle x. Okay, again, work out which sides we have. So this time we have opposite and hypotenuse. So, is it so? Yes. So, so tells us sin x is opposite over hypotenuse. So, 13/16. X then is the inverse sine of 13/16. Which gives us 54.3 degrees. Okay, next up, ABC is a right angle triangle. Work out the size of angle ABC. Give your answer to one decimal place. Okay, so angle ABC is the angle made by going from A to B to C. So it's this guy over on the right. I'm going to call it X. So, in terms of that angle, we have the adjacent and the hypotenuse. So, is it so? No. Ka? Yes. Ka then tells us cos x is 7/11. So x is the inverse cos of 7/11. Now that gives us 50.47 blah 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 to one decimal, that is 50.5 degrees. Cool. Okay then, part B. We're told the length of a B is decreased by 1 centimetre. So AB is the hypotenuse. It's now going to be 10. BC is still 7. The right angle is still a right angle. We are asked, will this increase or decrease the value of cos ABC? So, cos ABC was 7/11. cos ABC is now 7 over 10. Now, 7 over 10 is bigger than 7 over 11. We're splitting 7 into fewer parts, so it's increased. Okay, next up, write down the value of tan 45. So really, this is a non-calculator. It comes down to exact trig values. Foundation, I wouldn't worry too much. Higher, I have a brand new playlist on these guys with a video showing you how to calculate them, and exam questions like these. Check out the playlist down below. So, tan 45 is 1. Okay, then for part B, we have a right angle triangle with a 60-degree angle. We're told cos of 60 is 0.5. Work out the size of x. So, in terms of the angle, we have the adjacent and the hypotenuse. Okay. So, is it so? No. Ca? Yes. That's why they've told us cos of 60 is 0.5. So, using ca, we know cos 60 is 4 over x. Okay, now we need to move x up from the bottom of that fraction. To do that, we multiply both sides by x. So we get x cos 60 is 4. Now we need to get rid of the cos 60. Or we could now turn cos 60 into 0.5. So we could say 0.5x is 4. Now 0.5 is of course a half. To turn this into a whole x, we can multiply both sides by 2. So we get x is 8. Okay, now this one is a bit trickier. It involves ratio, which I know everyone loves. I do have 2 ratio playlists with exam questions like this. One for higher, one for foundation. I'll stick them down below. So, again we have a right angle triangle. The length AC is 14 centimeters. Angle C is 90 degrees. Angle B to angle A is in the ratio 3 to 2. Our job is to work out the length AB, giving our answer to 3 sig figs. So the guy that we want is the hypotenuse. Okay. What we need then is to find either angle A or angle B, and then we can SOHCAHTOA to our heart's content. To do that, we're going to need to play with the ratio. So, angles in a triangle add up to 180. We already have 90 in the right angle, so B and A together make up 90 degrees. So we need to split 90 in the ratio B to A, which is 3 to 2. Okay, so altogether the ratio has 3 and 2 equal parts. That's 5 parts. The first thing we need to do is work out how much one part is worth. So 90 divided by 5 is 18 degrees. So every one part of the ratio is 18 degrees. Then we multiply each side of the ratio by 18. 3 times 18 is 54. 2 times 18 is 36. So angle B is 54 degrees, angle A is 36 degrees. So we can play with either one. So I'm going to use angle A. Okay, so now that we know that, it's now a game of SOHCAHTOA. So we have the adjacent and the hypotenuse. So is it SO? No. Ka? Yes. So Ka tells us cos 36 is the adjacent 14 over hypotenuse x. Okay, now again we have the problem with x being on the bottom of the fraction. Multiply both sides by x. So x cos 36 is 14. Now the cos 36 is annoying us, it's multiplying x, get rid of it by dividing. So x is 14 over cos 36. Stick that in your calculator and 3 sig fix. X is 17.3 centimetres. Okay then, final page, part A, work out the size of angle X. Okay, so we have the adjacent and the hypotenuse. Is it SO? No. Ka? Yes. So Ka tells us cos X is 8/11. Which means then x is the inverse cos of 8/11. Which to one decimal place is 43.3 degrees. Okay then, part B. Work out the length y. Okay, so with respect to the angle, y is the opposite. And the 37 one is the adjacent. So, no, Ka, no, Toa, bingo. So, Toa tells us tan 40 is y over 37. So, multiply by the 37. And we're going to get y is 37 tan 40. Which, even to one decimal place, still just gives us 31 centimetres. Ignore the blue down there. Cool. Okay then, you heroes, hopefully this has helped you master SOHCAHTOA. If it has, please do give it a thumbs up, get subscribed to the channel. If you feel you've mastered basic trig, move on to the harder SOHCAHTOA problems, which will be linked down below. If you have any requests for topics you want done like this, let me know down below in a comment.